All right, what can I see? All right, hello everyone. My name is Ingel Patrick. I work on the layout team, and I thought I would give you a brief update, maybe not that brief, an update on all the things going on in the layout space at the moment. But first, we've sort of been on, the layout team's sort of been on like a journey over the past few years, slowly changing, like fundamentally changing the architecture of our engine. Most of you know what this is, it's layout-ng. I'll sort of give you a rough history of layout-ng and sort of where we've come from, where we're at, and what we'll be doing next. So the first sort of big thing was sort of in Q3, Q4 of 2019 when we sort of launched the first big bit. This was specifically all like most of block and inline layout. This accounts for by layout count by probably about 65 to 70% of layouts on the web. So it's a significant portion. And then over the sort of, start of the pandemic, basically, we slowly upgraded sort of layout mode by layout mode. So we launched Flexbox, tables, Microsoft, our friends at Microsoft did Grid, which was a huge benefit as well. And sort of this past year, we've been slowly getting the fragmentation engine launched. So it started with block fragmentation in Q1 this year. Myself, Morton, and Alison at Microsoft upgraded Flexbox, Grid, and table fragmentation. And that slowly launched over the course of this year as well. And finally, we've getting to launch printing. So hopefully in 108 or 109, basically, every single layout will be on layout-ng now, which is fantastic. The one thing that we've observed as we've gone through this is that one of the reasons we started with this layout-ng project was that we had a few fairly major problems. We had a really big quality problem. The number of bugs coming in and the rate at which we could fix them, just meant that, we could throw tons of engineers at this and, we wouldn't really make a dent. So this is, the count of all open bugs in the Flexbox component over time. Guess when we launched FlexNG? It's when the, bug count cuts by half. The sort of interesting thing to note here is that pre-FlexNG, the bug count goes up and to the right, and there's basically no stopping it. Now it's going down and to the right. So the thing that we've observed is that web developers are reporting fewer bugs, and also we can also easily fix them when they come in. So we can actually maintain a high quality Flexbox implementation. This isn't unique to Flexbox. This happened with Grid as well. This is open Grid bugs, open bugs in the Grid component. Again, up and to the right, sort of no end in sight to how many bugs web developers would find. Huge step up in quality of implementation, and then we can progressively stomp on them as they come in now. So it's been really great to see that's happened with Grid as well. Tables, similar thing with a caveat. The sort of uptick in we see the large drop as we usually see. The continual uptick isn't specifically table bugs, it's when people print tables. So there's a large quality of issue there that we're hopefully going to fix soon. And the final graph this is why printing is important. Basically, the number of printing bugs that we see just continually goes up. So we're hoping that after either the 108 or 109 release, where we'll see a very, very large drop in the number of open bugs in the printing component, and then hopefully we can start seeing it tick down over time as well. Which leads to happier web developers, which is great. The sort of other thing that we're pretty concerned about when we start this project is that we were largely bug for bug compatible with WebKit. And sort of the way things that were going at that time we were pretty concerned that like all of our WebKit era bugs sort of were slowly getting like baked into the platform. And I think we've largely mitigated that risk from the web with this project as well. Any questions on that at all? No? Sweet. The next big sort of thing that we saw sort of as we flipped things on was large uplift in performance. The sort of interesting thing about performance here is that we found that a lot of performance bugs that people run into day to day aren't sort of raw throughput as we typically think about performance. So, you know, we spend a lot of time with like motion mark or speedometer where we're trying to, you know, get an extra few percent throughput on something. The things that web developers really care about is when things go exponential. And we had these exponential bugs in block layout, we had them in Flexbox layout, and we also had them in grid layout. We also had them in multicol as well, but that was harder to hit. So this is a like very simple nested grid. Yeah, it's only like 20 layers deep type of thing. And you can see pre-grid NG, you know, we could take 10 seconds laying out the 20 divs on the left. After Microsoft shipped grid NG, you know, on the right, we take 1 millisecond. So that's, you know, 4 or 5 orders of magnitude speed up improvement. You might ask yourself the question, well, why would anyone nest, you know, 20 levels of, you know, grid? People do, happens all the time. But even, you know, like say that you've got a layout which is, you know, will take 10 milliseconds to lay out, and then you've got 4 layers of grid on top of that. Suddenly, you know, your 10 millisecond layout goes from 10 milliseconds to, what is that, like 160 milliseconds. So you get an order of magnitude blowout at least. The reason that this happens is that the newer layout algorithms in CSS are split into 2 phases. There's a measure phase, and then there's a layout phase. So on the left, we've got a measure phase. You can see we're just trying to work out what the height of everything is. And we go, aha, the thing on the right, the teal box is, say, 200 pixels high. I'm going to stretch everything so it's 200 pixels. And so then we relay out, we do a layout, and make everything 200 pixels. So that we've got a DROM structure like this. We've got, you know, grid or flexbox nested 4 times. And the thing on the left is dirty. So we need to measure it. Then we also need to measure its sibling as well. We need to measure the second level things, so we measure those. Then we measure the third level of things, we measure those. The important thing to note here is that in a measure pass, we also need to do a layout pass. So then we lay out the things at the bottom, we bubble up, we lay out the second level of things. But when we do a layout, we need to remeasure the children at the bottom. And so then we layer them out again. And so then you can see we lay out the top level, we need to measure that whole subtree again, that goes back to laying out, these lay out, measure, and we flip back and forth. And so that's where this exponential blowout comes in. So we had this exponential blowout in Flexbox, in Grid. Yeah, it was a bit of a mess, but we've largely mitigated that. We still have this bug in some cases for Grid because Grid can trigger 3 or 4 passes, and we only have 2 layout slots. So this is something that we'll likely work on next year to mitigate that final performance cliff that we've got. Next steps. First thing is delete all the things. So probably after print has gone stable for about a release, we'll let it bake, just in case anything you know, goes severely wrong, or we have to do merges in for the next release or anything like that. So likely early January, we'll be starting to delete, you know, bucket loads of code. I don't know how much exactly, but it will likely be in the realm of, you know, 100,000 lines of code from the code base. So expect like hopefully early January, potentially February, to see lots of the parts of the code base suddenly disappear, which will be a lot of fun. We also don't expect that this will be simple. It'll be very easy to delete, say, like old layout object classes that that have been around for a while. But there's sort of a lot of things in, say, like Paint and things in like methods on computer style, things in editing that will slowly be able to disappear as well. So we expect that this will actually take, it's not as simple as just deleting a whole directory and calling it a day. The next sort of project that we have is that currently, so say on the left, we've got our layout object tree, and on the right, we have built up this new tree called the fragment tree in layout.ng. The fragment tree holds all of the layout geometry information, but what we do today is that we explicitly copy back that geometry information into the layout tree. We copy back like the layout overflow, the size, the position, a whole bunch of other stuff. This is largely unneeded. We can likely read directly from the fragment tree to answer this sort of information. So Kent in Tokyo is going to be working on slowly removing back the things that we need to copy back, likely in Q1 next year as well. This will probably we see in traces that this takes anywhere from 3 to 5% of total layout time. So it's not huge, but it'll be nice to finally nuke that off. There's some other things as well that we want to slowly get rid of. So there's this phase called update layer positions after layout that we think that we can get rid of soon. On certain pages, this is just a fixed overhead of like 5 to 10% that we can just delete. It's not needed anymore. So we'll be doing like targeted performance improvements over the course of next year. The next stuff, I'll just quickly go through like things that we're actively working on at the moment. So the first thing is we're working on an implementation of initial letter. You can see that up on the left there. And on the right is some Japanese and vertical RL layout as well. This has been done by Yoshi in Tokyo. The implementation is actually pretty close to complete, and it's looking really, really good. We've got there's a lot of complex interactions with floats and stuff like that that we think that we've done a pretty good job on. So hopefully expect to see this in like Q1 next year or so, but we expect it'll likely be more or less code complete, this quarter or next quarter. The other one, we did a quick fix up on baselines. So these two items are aligned with their last baseline. So the text at the very bottom. We're likely going to start looking at potentially some like vertical rhythm or line grid type stuff. I've got some prototypes in progress at the moment, which is looking pretty promising, but sort of don't have any firm plans around that next. This is all the stuff that I didn't have pretty examples for that we're actively working on. So first thing is Koji is working on like anchor positioning. That's looking pretty solid. Really excited about that one. If you haven't seen examples of that, have a look at like Jahe on Twitter. He's got some really cool demos of it. After sort of like, like most popular requested features in the layout component is like subgrid, for example. But after that, printing features are sort of the next group of highly requested features. So sort of after Morton is sort of, stabilized and ship printing, he'll likely start to look at like some additional at-page print features. It's quite scary, but like Chromium is sort of the predominant producer of PDFs for like random use cases. So that'll be pretty exciting. Microsoft is obviously working on subgrid at the moment. This is predominantly Ethan and Kurt at the moment. Really, really solid progress. Really excited to see that land. And a whole bunch of other stuff. One small thing, like I'm personally working on, is intrinsic form controls, which is like automatically growing text areas. A whole bunch of other stuff we'll likely do next year as well, but it should be pretty fun. With that, I've got no idea what time I've done. 16 minutes, that's not too bad. That's all I've got. Any questions? Also happy to answer any questions not in this deck as well, any random questions they've got.
All right, got one in the audience.
How is Subgrid doing?
Subgrid is doing pretty well. There is some complexity that we sort of didn't realize with the spec initially. So I believe that I'll sign Ethan up for this now, and that likely next BlinkOn is the BlinkOn that you want to listen to. Ethan will likely have a presentation of all the details with Subgrid. But one thing that wasn't immediately obvious to us is that you need to effectively set up a tree of all of the subgrids and run them through the grid phases in sync. Otherwise, it gets very hairy around oh, my third level of nested subgrid depends on the rows and columns in what state. And you get into very, very hairy questions. The sort of Gecko implementation largely avoids this because they don't implement the second pass in grid layout. They don't implement steps 3 and 4. They don't recalculate the rows and columns. So if you don't do that, it's a lot simpler type of thing. So yeah, we're I believe we're the first implementation to sort of get all the hard corner cases. Yeah. Any more questions?
How do you or will you regression test printing? Hopefully not with dead trees.
Yeah, so predominantly we find that most people we say printing, but really we mean PDF generation. So we've got a suite of tests that will kick the renderer into a print mode and then do pixel-based testing on that. Or they'll have a reference HTML file and a test HTML file, and then they'll print both of those and then compare if they're the pixel the same. So that's predominantly how we test printing. Yeah, we don't have a suite of printers out back that someone hits print all the things and 1,000 things were up. That'd be cool, but yeah. But yeah, most of our bug reports from printing isn't from individual people printing web pages. It's from developers generating PDFs for invoices, or they're in a machine shop printing a cut list or something like that. And that's sort of why I've got way too many of those slides. This is why when you print, you're typically printing a table. So that's why we're seeing table bugs slowly tick up still, as predominantly they're all printing bugs. Okay. Cool, sweet. Thank you very much.